Welcome, my dear students. We have already discussed about ideal gas equation. Now we will go ahead regarding ideal gas equation. We have obtained ideal gas equation is PV equal to KT. This is the general ideal gas equation. But for 1 mole of a gas, the equation is PV equal to RT. This K is the constant of proportionality. It is for any given mass of a gas, this constant, but R is universal gas constant, where R is the universal gas constant. Now, this R is applicable for only 1 mole of a gas, but for n mole of a gas, the equation becomes PV equal to nR. So the equation PV equal to nRT is applicable for n mole of a gas. If the number of moles be 1, then it is PV equal to RT. But if the number of moles be 10, then it will be for 10 mole of a gas, it will be PV equal to 10 RT. Similarly, for 100 mole of a gas, PV equal to 100 RT. So more will be the number of moles, more will be the value of K. So the value of K is only constant for a given mass of gas. But when the mass of gas is changed, that is number of mole is changed, then the value of K will also be changed. So on which factor value of K depends in the ideal gas equation. This is the question. The answer will be, what is the answer? Mass of the gas or number of mole of the gas? Mass or number of mole of the gas. Note it or write down. Now we will establish the unit of R from the dimensional analysis of the equation PV equal to nRT. Unit of R. How will the unit of R deduced from the equation PV equal to nRT by its dimensional analysis? So we have obtained PV equal to nRT for n mole of gas. Or R equal to PV by n. So we have obtained R equal to P by n. Now by putting the dimensions of PV, n and T, we will get the unit of R. Now R equal to, therefore R equal to, P means pressure, into V volume, divided by n means number of moles into T means temperature. That is equal to, pressure can be substituted by force by area. The force applied on unit area is called pressure, into volume by number of moles into temperature. that is equal to force by length square. Area means length square, volume length cube divided by number of moles into temperature. Now length square and length cube cancel, we get A. So that is equal to force into length by number of moles into temperature. Now force into length equal to, if some force is applied and some displacement takes place, to get it equal, it is called work done or energy. Work by mole into temperature. So the final equation becomes, the final value of R will be obtained by putting the unit of work divided by mole into temperature. Now in CSC, in CE, value unit of R equal to, what is the unit of work? R. What is as unit of mole? R per mole into CGS temperature division. Now the value of R in CGS system has been obtained. Value. The unit is R per mole per degree Celsius. Its value has obtained 8.314 into 10 to the power 7 R per, can be written as mole inverse degree Celsius. This is the CGS unit of R, and this is the value, CGS value of R, 8.314 R per mole per degree. If the CGS unit be R per mole per degree Celsius, then the SI unit will be Joule mole inverse Kelvin inverse. Instead of watt, we can write Joule, and mole. Mole is the unit of quantity of substance, and temperature Kelvin, and its value can be obtained by dividing CGS value by dividing 10 to the power 7, because you know 10 to the power 7 R equal to 1 Joule. So in SI, it will be 8.314 into 8.314 Joule mole inverse Kelvin. 8.314 Joule mole inverse Kelvin. If you keep in your mind the value of R in SI system, 8.314 Joule inverse, Joule into Joule mole inverse Kelvin inverse, then in CGS it will be obtained by multiplying 10 to the power 7. Now there is another value of R. Value of R equal to, with respect to atmospheric pressure, it is 0.082 liter atmosphere or mole inverse Kelvin. So another value of R is 0.082 liter atmosphere mole inverse Kelvin. Keep in mind the values of R, and this R is applicable only for 1 mole of a gas. If the number of moles be greater than 1, it is 5 or 10, etc., then R will be multiplied by 10 or 5, etc. For example, pressure of a gas is such and such, volume is such and such, number of moles such and such, value of R is given, and temperature such and such given. And you can easily solve the problem by applying E equal to NRC. If any 4 are given, you will get the fixed quantity and you will be able to solve the sum. Thank you. For testing your understanding of this lesson and more videos, log on to www.cubelessons.net.